Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Okay, good afternoon everyone. So we proceed as usual Okay, before that please mark your attendance through Putra Blast. And then regarding the lecture note, I already uploaded the latest version of chi-square lecture note in our Putra Blast. Okay, and then please download the data set as well from there. Okay, I already uploaded the latest data set for chi-square. For the purpose of today's class. Okay, so this is our LO. Okay, at the end of the session, you should be able to determine the types of chi-square test. Okay, and then assumptions related to chi-square analysis, and then run the analysis and make the interpretation of chi-square based on the output result. Okay, and then prepare the report writing according to the APA style. Okay. Okay, so chi-square analysis. Okay, so chi-square, similar to what you already learned during statistic class. So the chi-square distribution has only one parameter, which is degree of freedom. Okay, in chi-square, we only consider the degree of freedom as the main parameter, as the parameter. Okay, so the shape of this distribution is skewed to the right. Okay, so all all the graph for chi-square will always be positively skewed, located in which it means that all the chi-square value should be positive. Okay, it shouldn't be a negative value for chi-square. Okay, for small it is positively skewed but becomes symmetric for large degree of freedom. Okay. The entire chi-square distribution lies to the right of the y-axis. Sebab tu tadi saya kata dia sebenarnya duduk belah kanan, sebab tu dia akan ada belah y-axis saja. Dia tak akan ada sebelah kiri. Okay, dia semua belah kanan. Okay. And then the chi-square distribution assumes non-negative value sebab all the chi-square value should be positive. Okay. So this is the example of chi-square distribution according to the number of degree of freedom. Start with 2, they positively skewed. Okay, degree of freedom 7, they start become symmetry, and then 12 dia lagi cantik. So the higher the number of samples, sebenarnya dia akan bentuk shape dia tu akan lebih symmetry. Okay. Okay, so we use chi-square analysis ni to test hypothesis related to distribution of observation. Okay, we will compare regarding it involve the comparison regarding the observation and expected values into particular categories with no inherent ranking. Okay, and then we are interested to look for patterns of observation. Okay, according to the categories, and will inform us if particular combination of the categories occur more frequently than we would expect by chance. Okay, so we are also interested to look for association between two categorical variables. In chi-square, we also can check on the association on the association between two categorical variables, both IVs and DV. Okay, last time we learned on how to test the association between variable by using Pearson product moment correlation or Spearman rank order. But now we are interested to check on the association between the two categorical variables by using the chi-square analysis. Okay, so types of chi-square, we have 3 types of chi-square. The first one, chi-square goodness of fit. Okay, which is the intention is to test how well a sample data match the known or assumed characteristic of the larger population that the sample is intended to represent. So this one is a compatible analysis to one sample t-test. Goodness of fit is a compatible analysis to one sample t-test, in which the data that we have, we want to compare with the previous study. Goodness of fit. The second one is test of independence, which is we use to test on association. Okay, we want to test on the association or the relationship between two categorical variables by taking into account the proportion of responses found in the combination of different categories of these two variables. So through test of independence ni, we are going to use contingency table ataupun cross tab. Kalau biasa guna pakai Excel tu, biasanya kita pakai cross tab tu sebenarnya lebih kurang sama dengan chi-square test of independence. Okay, the last one, test of homogeneity, which is we use it to test on the similarity of distribution between two population. Okay, we want to compare two groups. Okay, the similarity between two groups. Okay, we go to chi-square goodness of fit first. Okay, by the way, the calculation of the three type of chi-square is similar. We use similar formula. Okay, which is the value ni will be based on observed value, observed frequency, expected frequency, which is E ni expected equals to N times P. N represent sample size, P represent probability or proportion. Okay. Okay, so this is the chi-square goodness of fit. So it has been developed by Carl Pearson in 1980s. Okay, it is also known as one sample chi-square test. Or again, it is a compatible analysis, a compatible analysis to one sample t-test. Okay, sama. Cuma t-test, in one sample t-test, the DV must be continuous data and normally distribute. But this one is categorical data, categorical variable. Okay, we use frequency data from a sample to test hypothesis about population proportions. Okay, and then in which we want to tell how well the sample data that we have fits the population proportion specified by the null hypothesis. Okay, the aims is we want to compare the proposition of cases from a sample, which is the actual frequency that we have from our data set, with hypothesized values or those obtained previously by expected from comparison population. Kita nak bandingkan apa yang kita ada ni sama tak? Fit tak dengan yang sebelum ni? Okay. And then if the sample data do not fit the expected properties of the population that we are interested in, then we would not want to use this sample to draw conclusion about the larger population. We want to make sure that the data that we collect ni similar with the population that we want to represent. Okay. Okay, so the purpose, we want to compare the observed against expected frequency. We observe against expected frequencies in each category to test whether all categories have the same or user specified proportion of values. So basically the expected ni referring to the previous data that we have. Expected ni referring to the previous data or existing data that we have. Okay. Okay, this is the example, a hypothesized proportion based on the overall population. 30% are smokers, 70% non-smokers. So we conduct one study, then we collect the data among a group of sample. We want to check either the current sample that we have ni has shared similar distribution or proportion with the overall population. Itu dia punya intention. Okay, the requirement to run the chi-square goodness of fit. Okay, the analysis involve on one variable only. The analysis involve one categorical variable only. Okay, sama macam dalam one sample t-test. Okay, and then the number of group must be larger or equals to 2. And then the group ni, the variable ni referring to nominal or ordinal. Okay, nominal or ordinal. Okay, and then data in the cell should be frequencies or counts. Hold on, Okay, dah. Okay, so data in the cells ni should be in frequency or counts only, meaning that the actual reading sama ada dalam bentuk frekuensi ataupun bilangan. Okay. Okay, so the expected frequencies or each category should appear only once in the data, meaning that it must be mutually exclusive. Dia tak boleh appear twice. Okay, for number of group equals to 2, the expected frequencies should not be smaller than 5 for more than 20% of the total expected frequencies. Okay, this one nanti kita akan check. This one we will check after we run the analysis. Nanti kita akan tengok. We will test this assumption, this requirement after we run the analysis. Okay, if we have small expected frequency case, so we need to run the binomial test in which it will not be covered in this course line. Kita tak cover this one. Okay, for group number then for number of group larger than 2, the expected frequencies should not be smaller than 1. Kalau group sama dengan 2, bilangan group ni sama dengan 2, the expected frequencies ni shouldn't be smaller than 5. But for number of group larger than 2, the expected frequencies ni shouldn't be smaller than 1. Okay, 5, 1. 5 ni for number of group equals to 2. For group larger than 2, it shouldn't be smaller than 1 for more than 20% of the total expected frequencies. Okay, and then kalau dalam in the case of expected frequency of less than 5 ni exceeding 20%, okay, so it is strongly recommended for us to reduce the number of categories. We combine. If let's say we have 3 categories tadi, the group tadi 3, we combine the 3 to becomes 2. Okay, we reduce the number of category to make sure that the number of case ni exceed 5%. Exceed 5. Faham ni Okay, assumption. Data should be based on random sample. There is no requirement for the shape of data distribution because this is a non-parametric statistic. So there is no requirement for data to meet the assumption of normality, only based on random sampling only. Okay. Okay, so what to expect? Similar from previous. Okay, so we need to remember the 5 steps: state null and research hypothesis. Identify the test statistic based on the Ibm Spss output. Okay, and then determine our alpha, make decision, and lastly make our conclusion. Okay, so this one boleh laju. Okay, this is the example of a hypothesis for chi-square goodness of fit. Okay, so null hypothesis will indicate the statement of assumption. And then our research hypothesis will indicate statement of opposite of the assumption. For example, observed frequencies are equal to expected frequencies. Contoh and then maksudnya there is no differences between the observed and expected. Okay, and then our research hypothesis stated that observed frequencies are different from expected frequencies. We indicate the differences in reading between both values. Okay. Ni another example. Okay, to be more specific, respondents are equally happy about their married life. Contoh. Okay, respondents are equally happy about their married life for our null hypothesis, and then for our research hypothesis, not all respondents are happy about their married life. Okay, our research hypothesis, not all respondents are happy about their married life. Okay, now we want to extract the chi-square value. Okay, please open the data set that I've shared through our Putra Blast, or I will share again here. Okay, please download the dataset shared in our chat box and open the dataset. We will use that one for goodness of fit and test chi-square test of independence. Ready? Belum? Ready?
Ready.
Okay. To start to run the analysis, now click analyze, click non-parametric test and click legacy dialog. Okay, analyze non-parametric test, legacy dialog and chi-square. Analyze non-parametric test, legacy dialog, chi-square. Okay, next. Okay, choose HAPMA, happy marriage, happy married, HAPMA variable. Okay, from your data set, HAPMA. Okay, choose HAPMA from your data set and locate under test variable list. Okay. Under the expected values ni, if you have a specific values from previous study or from previous scholars or previous report, you may include under the values. If not, you can just tick all categories equal. Dekat expected values ni, kalau ada dapatan daripada kajian lepas, you can indicate here the values here, add accordingly. Okay, kalau tak ada, just click, just tick on add all categories equal. Okay, and then click OK. Senang je untuk buat chi-square goodness of fit. Then, okay, go to our SPSS output. Okay, the first table, the frequency table, we refer to the expected value. So the expected ni will represent the average score if all categories were equal. Kalau semua equal, sebab we have the our sample is 1337. So kalau dia equal, dia akan semua akan dapat 445.445.7 equal expected values. Okay, and then the residual ni will indicate the difference between observed and expected. Observed minus expected equals to residual. Okay, observed minus expected equals to residual. Okay, so biasanya untuk tengok perbezaan ni senang, kita tak payah, no need for us to manually calculate, we just refer to the residual. Residual ni will indicate how much the difference between the observed and expected. Okay. Okay, so based on the residual value, okay, so we clearly can see there is a difference between the degree of happiness among respondents. We can see that there are different degree, different level of happiness. Some of them say that they are very happy. Some of them say that they are not too happy. Tapi adalah 37 indicated that they are not too happy. Okay, pretty happy, ada sikit, very small, but most of them said that they are very happy. Okay. Okay, so then to check either our result is significant or not, okay, we refer to the asymptote significant value. Okay, this value we will use to infer or make our conclusion letter. Okay, so last time, previously I said that there is a requirement that we need to follow. So regarding the if the number of category equals to 2, okay, then it shouldn't be less than 5% for 20%. The value shouldn't be 5. Shouldn't be less than 5 for 20% cell. Okay. So this one, the note indicate that 0 cells have expected frequencies less than 5. So the minimum expected cell frequency is 445.7. So which indicate that our result is valid. Our chi-square goodness of fit result is valid. Okay. Okay, so we set our alpha value. Okay, then make our decision. So to make our decision similar with previous analysis, we just compare the result, our significant value against alpha. Okay, so since the significant value, the significant chi-square 0.000 lesser than alpha 0.05, therefore we reject the null hypothesis. Okay, so the conclusion, since we reject the null hypothesis, we indicate that there is a significant difference from the assumption. There is a significant difference in respondents' happiness for their married life. Okay, so this is our conclusion. So not all respondents are equally happy from their marriage, and the proportion across level of happiness are statistically different. So this is the conclusion that we can make after we reject the null hypothesis. Okay, so in terms of writing, a chi-square goodness of fit test was computed for comparing happiness of marriage. Okay, so 1 referring to very happy, 2 pretty happy, 3 not too happy in equal proportion. So we estimate that the respondent will distribute it equally. Okay, but statistically significant deviation from the hypothesized equal proportion was found. Okay, chi-square equals to 750.7, significant value lesser than 0.05. Okay, so this is the example on how to report the chi-square goodness of fit result according to APA style. Okay, so this is APA table presentation style. Okay, for the output. Okay, any questions so far? Ada soalan?
Doctor, if we want to reduce the category, how to decide which category to be combined? Either 1 combined with 2 or 2 combined with 3, or we can either choose.
The one close to the value. For example, we use the scale 1, 2, 3. Okay, so probably from the very beginning we use 1, 2, 3 to represent 1 not happy, 2 pretty happy, 3 very happy. Right? Okay, so then to reduce the number of category, we just divide by 2. Happy, not happy. That's it. To increase the number of respondent for each category. That's all. We create with a new one.
Oh, maknanya kita bukan daripada 3 tu gabung 2. Bukan macam tu kan?
No.
Rasa dulu belajar yang ni panggil collapse tu kan doktor kan?
Yes,
collapse.
We can
Sebab rasa belajar yang sebelum ni tu dia combine 1 dengan 2, lepas tu 3 dia biarkan kekal 3 macam tu.
Dia depends on the scale jugalah. Tapi kalau macam contoh not happy tadi, macam not happy, so it is prone towards the negative lah. Okay, tapi tadi pretty happy and very happy tu prone towards positive. Kan? Tapi kalau maksudnya if let's say we reduce, we come up with a new scale, then probably it is not fair lah for those who said that, for those who indicated that they are pretty happy. Not obviously not happy with the marriage. Tapi depend on the situation. Kalau let's say we have the beginning tu, at the start tu we have 4 scale, contohnya 4 scale. 2 for example not happy, slightly not happy, contoh. So this one we can combine 2, and then the next one above positive tadi tu, the positive scale tu, then 2. Kita buat kita combine becomes 1. So depending on the scale as well. Boleh? Okay.
Thank you.
Thank you juga sebab tanya soalan. Okay, ada lagi soalan? Okay, ada Then we proceed with chi-square test of independence. Okay, so chi-square test of independence ni similar to test of association. Okay, we are interested to see on the association between the 2 categorical variable. Okay, so the aims is to find whether the 2 qualitative variable or categorical variable are independent of each other or related. Independent of each other ni means that not related to each other, or they are related to each other by taking into account the proportion of responses found in the combination of different categories of each of the 2 variables. Okay, so it is also known as test of association. Okay, in which we seek to test the relationship between 2 categorical variables. Okay, so this analysis involve using contingency table of observed data values. Sama macam cross tabulation. Okay, the purpose, we want to test the association between two categorical variables, and then we can determine based on the result, we can determine the strength of the association. Okay, based on the result, after we test the association, either exists or not, then we can determine the strength or the magnitude of the association. In terms of the requirement, okay, the DV must be nominal or ordinal, same goes to the IV, nominal or ordinal. But at least one of the variable must be in nominal scale. Okay, salah satu, tak kisah mana-mana tapi salah satu. Okay, and then the calculation based on frequencies rather than numerical score. Okay, based on actual data frequency. Okay, so the assumption, there must be at least two categories for each of the two categorical variable. Mesti dua, sekurang-kurangnya dua. Okay, and then the observation in each group should be independent and expected frequencies for each category should only appear once, mutually exclusive. Okay, the sample size should be large enough to ensure that the expected frequency in each cell is at least 1, and then the majority of cell have the expected count of at least 5. Kurang-kurangnya 5, 1 ataupun 5. Okay, so saya skip this part. So hypothesis test, kita ada 5 step sama macam yang sebelum ni. Saya boleh laju sikit kat ni. Okay, so step number 1. So this is the example of hypothesis for chi-square test of independence. Okay, the null hypothesis, the two variables are independent of each other, or the two variables are not independent of each other for our research hypothesis, or we can specify. Okay, we can write it in more specific way. There is no association between variable 1 and variable 2 for our null hypothesis, and then for our research hypothesis, there exists an association between variable 1 and variable 2. Okay, and then for the example, for our case, in null hypothesis, we will state as there is no association between happiness of marriage and general happiness. There is no association between happiness of marriage and general happiness. And then our research hypothesis, there exists an association between happiness of marriage and general happiness. Okay, dua. Okay, then to run the analysis in Ibm Spss, okay, click analyze, click descriptive statistic, and click cross tab. Okay, and analyze descriptive statistics, cross tab. Then in the cross tab box, you locate HAPMA, happy marriage, happy married, under the row column. Okay, and then happy general happiness, which is happy, under column. Okay, HAPMA row, okay, happy column. Okay, and then click statistics. Okay, click statistic, and then click chi-square, click pi and Cramer's V, pi and Cramer's V, click continue. Okay, then click cell. Under cell, click count, for counts, click observed and expected. For residual, click unstandardized. Observe, expected. For residuals, unstandardized. And then click continue. And then click OK. Okay, go to our output, then refer to the residual column. Residual row. Okay, so based on the residual ni, okay, it indicate that the variable are not independent variable because there are differences between the expected count and the actual count. Count to the actual data or the observed value. Count referring to the observed value. Count observed value, expected referring to the expected lah. Okay, residual ni referring to the difference between count and expected. Okay, if there are differences between the two values ni, meaning that the variables are not independent. If you use the word not independent, means that they are related. Okay, they are related to one and another. Okay, so in other words, we can say that happiness of marriage and general happiness are related to each other based on the findings here. Okay. Then we go to the chi-square test table. Okay, based on this the chi-square test table, we refer to Pearson chi-square value. Okay, which indicate the asymptotic significance equals to 0.000. So this one we will use for decision making purpose later. Okay, so then the note after the chi-square test table, one cells which is 11.1% have expected count less than 5, which is the minimum expected count is 1.98. So one of the 9 cell, okay, 9 cells sebab kita 3. There are 3 categories for each variables, okay, with an expected frequency less than 5. So requirement dia 5 lah kalau more than 2 groups. Okay, so too many low count cell which is more than 25% is one accepted criteria. So the overall chi-square value here indicated that the reading or the output is valid. Okay, and then which value to report, because for chi-square test of independence, after we determine either the association exists or not, we can report the strength or magnitude of the relationship. So which value to be reported? We use pi square, we choose pi coefficient, sorry, we use pi coefficient only for 2 by 2 contingency table. But in this case, it is 3 by 3. 3 by 3. Okay, so therefore, in this case, we report the Cramer's V. We can report the Cramer's V instead of the pi coefficient. Okay, then to read the value, to determine or to interpret the value, the magnitude of the relationship, we can use the Guilford rule of thumb. Okay. Okay, so this is criteria. This is the criteria earlier. So it is the chi-square output considered to be invalid if more than 1/5 or 20% of the cells with expected count less than 5. Okay, so we can avoid by what we already discussed just now. We collect larger sample, we increase the number of sample, or we combine data for the smaller expected categories until their combined value is 5 or more. Ini macam yang tadi lah. Okay, kita reduce the number of categories. Okay, so this is how to represent our output lah. Ini lagi nampak lah kalau dalam graph macam ni lagi nampak. Okay, okay, and then we make the decision. So we come to make the decision, we just compare the significant value against our alpha. Okay, so in this case, since significant chi-square test of independence 0.000 lesser than alpha 0.05, therefore we reject hash not. Okay, so for conclusion, since we reject, we can indicate that there is a significant association between happiness of marriage and general happiness. General happiness. Sampai situ je. Okay. Okay, and then to report the magnitude of the relationship, we use the contingency tadi. We use the Cramer's V coefficient tadi. Lupa. Kita tak take for coefficient contingency tadi. Okay. So we can read according to we can interpret the value according to the Guilford rule of thumb. Okay. Okay, so this is the reporting style for the finding. So a chi-square test of independence was performed to examine the relationship between happiness of marriage and general happiness. So the relationship between the two variables was significant. Chi-square equals to 424.839, which is significant value lesser than 0.05. So the two, those who have happy marriage tend to have a happy life. This is the conclusion. Okay, any question? This is the APA table presentation style for chi-square test of independence. Any question? Senang je tak? Okay, nak ada. Last. Chi-square test of homogeneity. Okay. So chi-square test of homogeneity, we use this analysis to draw conclusion about whether two populations have the same distribution or not. we want to compare two data set. Either the two data set, either the two population ni share similar distribution or not. Okay. We want to calculate the test statistic for a test for homogeneity, follow the same procedure as with the test of independence. Procedure dia sama dengan test of independence. Okay, so the expected value inside each cell should be at least 5 in order for you to use this test. Make sure kita kena ada ample sample size. Okay, sekurang-kurangnya for each cell, dia kena ada sekurang-kurangnya 5. Kalau 5, for example, if you have 3 categories, so 15 minimum. Okay. What to expect? Hypothesis test sama. We follow the 5 step. Okay. Laju. Okay. So example of null hypothesis, null and research hypothesis for chi-square homogeneity, test of homogeneity is, okay, the null hypothesis. Ni terbalik dua-dua ni. Sorry lupa nak tukar. Yeah, our null hypothesis, then the distribution of the two populations are the same. Okay, our research hypothesis, the distribution of the two populations are not the same. We are interested in the differences between the two population. Okay, example. Okay, for null hypothesis, the distribution of race for male employees is the same as the distribution of race for female employees. Taburan pekerja perempuan dengan pekerja lelaki sama. Okay, our research hypothesis, the distributions of race for male employees is not the same as the distribution of race for female employees. Okay. Okay, then to run the analysis, we use the chi-square test statistic, which is it is compute in the same way as the test for independence. The step point should be similar, sama, but the intention is different. Okay. In terms of the requirement, all values in the table must be greater than or equal to 5. Minimum number mesti 5 untuk setiap cell. Okay, the common use, okay, to compare the two population. For example, we want to compare between distribution of men and women, okay, before and after, east and coast, east and west, contoh. Okay. The variable is categorical with more than 2 possible responses value, which is the number of group tu mesti at least 2. Okay. Okay, to run the analysis, this one we use our data set. Our data set kot. Betul. We use our data set which is ERS5951 data set. Ready?
Ready.
Okay, to run the analysis, we click analyze, click descriptive statistic and click cross tab. Okay, analyze, descriptive statistic, cross tab. Analyze, descriptive statistic, cross tab, the same procedure as what in chi-square test of independence. Okay, and then in cross tab box, we choose gender and locate under row, race for column, okay, gender row. Okay, next click statistics. For statistic, we are only interested in chi-square value. Okay, chi-square. Itu saja. Then click continue. Okay, next click cells. Okay. For cell, under counts, tick for observed and expected, and then click continue. Okay, and then it show the result. Okay. Proceed to the chi-square test table. Refer to the Pearson chi-square column. Row. Column. Okay. Asymptotic significance, two-sided. Okay. So the value indicate that the significant value equals to 0.000. Okay. So to make decision, we refer to the asymptotic significance. So this value we'll use to make the decision. Okay. Okay, so based on the result, okay, so seeing the significant value 0.000 lesser than alpha 0.05, therefore we reject the null hypothesis. So in this case, it indicated that the distribution of race is not the same across gender. Okay, taburannya tak sama. Okay. So this is an example of APA reporting style. Okay, so a chi-square test of homogeneity was run, was run to analyze the distribution of race according to gender in an organization. So based on Pearson chi-square values row, it was indicated that chi-square equals to 40, okay, and then the significant value equals to 0.000. So this result informed that the distribution of race for male employees is not the same as the distribution of race for female employees in the organization. Done. Ada soalan? Simple saja untuk chi-square. Any question? Today is supposed to be our last lecture. Soalan final saya dah share belum? Tapi tak payah share kot sebab our exam will be on 14 and 15, right?
Yes.
Dah. Minggu lepas saya dah share soalan exam kan? Belum eh?
Belum.
Tak payahlah share dah 2 hari tu. 2 hari tu exam tu.
Okay lah.
Okay, baik. Share. Okay, saya share tapi tak share screen lah Saya bagi tips saja. Okay, for the final exam question, there are 2 sections There are 2 sections, section A and section 1 and section B. Section 1 is MCQ, consists of MCQ questions that will contribute 20 marks and consists of 20 questions. Okay, 20 questions will contribute 20% of the overall mark. Boleh 20 soalan. So this is about the general knowledge lah, starting from first lecture until the last lecture. I thought it's quite easy lah, insyaAllah. Okay, and then section B consists of 7 questions. 7 kejap. Saya tengok 7 kot. 7 questions, and then you need to answer all the questions. Okay, 7 questions, answer all the questions. Okay, the output already provided to you. Semua output ada. Okay, what you need to do is only extract the values, extract the statistical result according to the question indicated. Okay, soalan yang masuk the question included in the final exam will be soalan apa ni? ANOVA, two-way ANOVA, starting from ANOVA, two-way ANOVA, two-way ANOVA, lagi. Correlations. Regressions. Itu sahaja. ANOVA, correlation and regressions. Confirm boleh lulus punya ni. Tiap jari je ni. That's all.
Section B weightage dia berapa persen?
80%.
80%.
For section B, 80%. Okay, the question will included in from a one-way ANOVA, two-way ANOVA, one-way ANOVA, two-way ANOVA, chi-square tak ada kot. Chi-square tak ada. Ada ke tak chi-square? Rasa macam tak ada kot. Salah.
Doktor, 7 soalan tu 7 soalan utama kan? Dia ada beranak-beranak dia kan?
Yes, dia ada anak-anak dia. There will be small question under each big question. Okay, 7 question. Dia ada one-way ANOVA, two-way ANOVA, correlations and regressions. That's all. It should be very easy one lah. Tiap jari je ni. If you can score A for Prof Bahaman's class, this one you can score A+++.
Okay.
You can score A+++ for this course. No worries. Okay, so any other question? That's all lah, habis dah. We already done with our lecture. I'm done with the lecture. So any question regarding your assignment? Senyum je semua, happy je tengok. Because some of you already enjoy your final semester. So I don't want to trouble you. Buat mudah-mudah je. Okay, any questions so far? Tak ada. Final exam, assignment should be okay, right? Okay, so if there is no question, so we stop here. Okay, enjoy your study break next week. So this is our last lecture. So please mark your attendance and then please fill in the teaching assessment form as well. Okay, please fill in the teaching assessment form. I really need that form. I really need the form. Okay, I don't care about whatever you insert into the document, into the form. I don't care, but at least you fill in the form. Sebab kalau saya tak dapat benda tu, nanti saya akan disoal kenapa tak dapat, kenapa tak diisi, kenapa tak suruh student isi. Okay, at least I got the marks lah from there. Okay, ada lagi soalan tak? Tak ada dah So insyaAllah that's all for today. So I wish you all the best for the final exam and then please submit your assignment accordingly. So I thought I already uploaded all the assignments, right? Semudah kan? Dah. Okay, tak ada hutang dah. Okay, so thank you guys. Assalamualaikum.
Terima kasih Dr. Lami.
Thank you, Doktor.
Tak ada apa-apa.
Thank you, Tata.
Thank you.
Thank you, Doctor.
Take care. Assalamualaikum.
Assalamualaikum.